All right, so this first word problem says you need to score at least 90 points on average. It should say on average, but it doesn't. To advance to the next round of the touchscreen trivia game. What scores in the fifth game will allow you to advance? So it's very small to see when we're looking at it like this, but the scores that we see here, I think, are 95, 91, 77, and 89. Now, this should say you need an average score of at least 90 points. There's 5 games. Here are your scores for the first 4. To find an average, you take all of the scores up, you add them, and you divide by how many numbers you have. So in order to find out what the fifth score would be, I would have to have my fifth score being a variable. You can call it like X. And this will be the fifth score that you would have to have so that all of these would average up to be 90. To find the average, you add up all of the scores and you divide by how many there are. 1, 2, 3, 4, 5. And in order to advance to the next level, the average must be at least 90 points. So then I could create an inequality by then taking this average, which represents the average, at least 90 points would be greater than or equal to 90, like that. So in order to solve this, the first thing I would do is just add up those 4 scores. 95 plus 91 plus 77 plus 89 is 352. So to simplify this a little bit, it'll be 352 plus x all over 5 must be at least 90, which would mean greater than or equal to 90. Yes?
I was around yesterday and I left my bag at my house. Can I just use this paper?
That's fine. And then to solve this thing, you could do a couple things, but I kind of want to get rid of this divided by 5 so that there's no division at all. To get rid of divided by 5, we multiply both sides by 5. When you multiply this entire fraction by 5, these 5's cancel out, and I'm left with 352 plus x on the left. And 90 times 5 is 450 on the right. The last thing I would do then is subtract both sides by 352. And we're going to get that the last score for the game must be greater than or equal to 98 in order for you to advance to the next level. So you must get it greater than or equal to 98 points to advance. Now these problems don't ask us to graph. If the problems don't ask you to graph, you don't necessarily have to. So we can skip the graph for now, but that would be a closed circle at 98 with the answers pointing to the right. Each one of these questions were a little bit different, so the number 2 is going to be completely different than number 1. Number 2 is another application problem. It says that the area of the rectangle shown is at most 140 square centimeters. Write and solve an inequality to find the possible values of x. Well, how do you find an area of a rectangle? What do you do? Area of a rectangle. Anyone? Multiply. Yes. So we multiply the length times the width to find the area. So if we have here that like the length, let's say, is 10 centimeters and the width is 3x plus 2, the area, to find it, I would multiply 10 times 3x plus 2. That's what the area would be. Now, normally when you have a rectangle, you just have like numbers for the length and width. You would just multiply them. In this case, we have an expression for the width. The area of this rectangle is at most 140 square centimeters. What symbol would I need here to show that it's at most 140? Molly?
Less than or equal to?
Perfect. Less than or equal to. So this is the inequality you would create from that word problem, and then you would solve it to figure out what the possible values of x would have to be in order for this to be true. To do that, you would distribute 10 times 3x is 30x. 10 times 2 is 20. So we get 30x plus 20 is less than or equal to 140. Then we would solve this two-step inequality by first getting rid of the plus 20 by subtracting 20 from both sides. We get 30x is less than or equal to 120. And when we divide both sides by 30, we're going to get x is less than or equal to 4. That means that the possible values of x would either be anything less than or equal to 4, like anything like 1 would work, 2 would work, 3 would work, 4 would even work, but 4 would be the limit there. All right, number 3 is different than number 1 and number 2. Number 3 says you must maintain a minimum balance of $50 in your checking account. You currently have a balance of $280. Write and solve an inequality that represents how many $20 bills you can withdraw without going below the minimum balance. So, you must have at least $50 in your checking account. The minimum that you can have is $50. So no matter what's going on with you withdrawing money, you have to have at least $50. So I'm going to have my expression on the left, but I know this all has to be at least, which is greater than or equal to $50 in your account. You currently have $280. So this is your current amount, $280, and you're withdrawing $20 bills. Withdrawing means take out. So you're taking out $20 bills to go buy stuff. So if we are using X for the number of $20 bills, then every time you take out a $20 bill, you would have to multiply X, that number of them, by 20. Because if you take 2 bills out, then that's 20 times 2, that's $40. So when you're withdrawing, you're taking money away. So for every $20 bill that you take away, it would be $20 times X. So this inequality says you start with 280, you're withdrawing $20 bills, and your balance must be greater than or equal to 50. So we would go ahead and solve this thing by first getting rid of this 280. What's weird about this problem is this is subtraction here, but the only way to get rid of a positive 280 is by subtracting 280. When you're looking at subtraction symbols and addition symbols, you have to look at the actual number and think to yourself what you can do to get rid of that. This minus sign goes along with the 20x. It makes it a negative 20x. It does not have anything to do with the 280. So you have to actually subtract both sides, even though the problem has subtraction in it. 50 minus 280 is negative 230. So we get negative 20x is greater than or equal to negative 230. The last thing we would do is get rid of the negative 20 times x by dividing both sides by negative 20. And we just have to be careful when we do this. When I divide by negative 20, I'm going to get x on this side. Negative 230 divided by negative 20 is interesting because it's 11.5, which we'll talk about what that means in a second. And then when you divide by a negative, what happens to the sign? Yeah, it switches. So it's going to be less than or equal to. So usually when we have a problem that we would need to round, we would round to either 5 and above, give it a shove, like round up, or round down, depending on the decimal. In this case, if we were following regular rounding rules, we would round this to 12, because 5 and above, give it a shove, we would just round this to the nearest whole number, because you can't have a fraction of a number of $20 bills. I mean, I guess you can, but it doesn't really make sense. But if you round this up to 12, it actually won't work. Because if you take 12 $20 bills out and you put it in here, your minimum balance will not be greater than 50. Because 12 times 20 is 240. And 280 minus 240 is $40. It has to be greater than or equal to 50. So this is an interesting one because since we can't have a fraction of a $20 bill, we actually have to round this one down. The final answer would be x is less than or equal to 11. You would take out less than or equal to 11, 11 at the maximum amount of bills in order to have that minimum balance of at least $50. And then the last one, number 4, was different than all the other ones. So the graph shows your budget and the total cost X gallons of gasoline and a car wash. You want to determine the possible amounts of gasoline you can buy with your budget. So we have 2 lines here. We see that this graph is about the amount of gasoline in gallons, which is representing X, versus the amount of dollars, which is representing Y. We have one straight line that says Y equals 40. That means that the dollars equal 40. That is how much money that you have. Just Y equals $40 is your budget. So I can tell that because this line is just showing that you have Y equals 40, which is just going to be the amount of money you have. You have $40. So I can tell that from the blue line here. They tell you in the problem that X is representing the number of gallons of gasoline. Y is representing dollars. I can see it on the graph as well that the amount of gasoline in gallons is down here. So when it's asking how much does a gallon of gasoline cost, you have to look at the red line. The red line says the amount of money, because that's what Y is equal to 3.55 times X. X represents the amount of gasoline you're buying, plus $8. So this number right here, this 3.55X, since X represents the number of gallons of gasoline, 3.55 represents how much it costs per gallon of gasoline. So the amount per gallon is $3.55. Which means how much would that car wash cost? They didn't really tell us in the word problem itself. You'd have to figure it out from the numbers. How much money does a car wash cost?
$8.
Yes, it's $8. And I can tell from the equation here because this says money equals $3.55 per gallon plus $8. So that means the car wash must cost $8. And then letter D is asking us to then finally create an inequality. It says write an inequality that represents the possible amounts of gasoline you can buy. Well, the equation that represents the amount of money we can spend is 3.55 X plus 8. And we know that our budget is $40, so we can spend at most $40. Now, we can spend exactly 40. So if this was in an equation in Chapter 2, I would have 3.55x plus 8 equals 40. But because this is the inequality chapter, technically you don't have to get exactly 40. You can also get less than it. So it would be less than or equal to $40. And then you would go ahead and solve this. So you would subtract both sides for letter E. It says what's the maximum number of gallons you would buy. That would mean to solve this inequality. So when you're solving this, you subtract both sides by 8. You get 3.55x is less than or equal to 32. And then do 32 divided by 3.55. You're going to get x is less than or equal to about 9. So the maximum number of gallons you can buy with your budget is 9 gallons. Okay. All right, so that's section 2.4, applying our knowledge from inequalities. Now let's get into some more difficult stuff. So the last thing we're going to do today is start section 2.5 notes, which is on compound inequalities. So if we think back, I know it's been a while because we had math testing in between all of this. Then we had, I feel like just some days off. Yeah, we had some professional days for the teachers. You guys had also. I feel like we've been doing this chapter for a long time. But we started in 2.1 solving inequalities with addition and subtraction, then multiplication or division, then multiple step inequalities, and then application problems and inequalities with no solution and all real numbers as solutions. The last thing that we're going to do is solve compound inequalities and absolute value inequalities. This is where this stuff gets really tough. So maybe so far you're feeling okay about this section. This is going to be new. I don't think that you guys ever covered this in pre-algebra, so this is going to be a new concept. Our test next week is going to have everything in Chapter 2. We decided not to do a quiz and then another quiz or a quiz and a test. We're just going to do one Chapter 2 test because it does take so long to, with the hybrid model, like it takes, every lesson takes so long. If we do multiple tests, that's going to take multiple days. So our test is going to focus on the hard stuff, not necessarily all of the easier things that we saw in the previous sections. So, in section 2.5, we're going to write or solve compound inequalities and graph their solutions. So, this opener here is asking us what the difference is between the following statements. You can leave work 30 minutes early or take a 30-minute lunch break. You can leave 30 minutes early and take a 30-minute lunch break. What's the difference between these two statements? Molly? Yes, so one uses or and the other one uses and. And that is going to change it a lot because in the first one, you can only do one thing. Either leave work 30 minutes early or take a 30-minute lunch break. The second one sounds better because you can do both. You can leave 30 minutes early and also take a 30-minute lunch break. So you actually get more time off in the second one than you do in the first one. So that's what this means in this section is we're going to be looking at and or statements for these types of inequalities. So in example 1, the graph of a compound inequality with the word and is the intersection of the graphs of the inequalities. The graph shows numbers that are solutions of both of them. So you're going to see this stuff here, and it's going to look really confusing because you have, first of all, two numbers in it, you have a variable, and you have two symbols. Well, when you read these statements, these are called compound inequalities. And when you read them from actually the center to the left and then the center to the right. The center meaning that the variable in the middle is where you start reading. We're usually used to reading from left to right, but when you have a compound inequality, this is meaning you have two inequalities in one problem. You actually read it from the middle to the left and then the middle to the right. The middle to the left says x is, if we're reading it this way, we're not used to reading from right to left, but if we read it this way, this says x is greater than or equal to 2. So that's what this means here, this first one. And then when you read it from the middle to the right, that one is just x is less than 5, like we're used to seeing when we normally read from left to right. The only one that's weird is when you're reading from right to left, everything is kind of backwards. When I see something like this, you read it as x, and then you read it going this way. It's greater than or equal to, and then 2. So compound inequalities means that the answers are either going to be in between two endpoints or to the outside of two endpoints. So this says any number that's greater than or equal to 2 and also less than 5. Now back with the beginning stuff when we were graphing, anytime you have a less than or equal to symbol or a greater than or equal to symbol, it's a closed circle. So let's not forget that. And anytime we have a less than or greater than symbol, it's an open circle. The two numbers that we need on our number line are 2 and 5. So I guess I could put 2 here since I know 2 is smaller than 5. 2, 3, 4, 5. I know there's 2 endpoints because this says 2 numbers here. So you need 2 numbers on your graph now for this problem. Anything greater than or equal to 2 would be a closed circle at 2, and then the answers are going to be going to the right. Anything less than 5 would be an open circle at 5, anything to the left. So here's what this graph looks like. So notice the difference. We now have 2 numbers on the graph because we have 2 endpoints, and the answers are between these 2 endpoints here. Do you not have your packet? Okay. You should be writing things down with me. So what are some possible solutions of this inequality? Molly? Yeah, 2, 3, 4. Could we have 5 be an answer? Nope, 5's not an answer because it's an open circle. Could we have decimals as answers? Like, would 3.3 work? Yep, so basically we could keep going. It's any numbers that would be inside of these limits. 2 including 2, up to 5 but not including 5. This is called an AND statement inequality. When we have the word AND, the answers are between 2 numbers. When we have the word OR, the answers are not going to be between, but they're going to be on the outsides of 2 numbers. So this graph of the compound inequality says the word OR. And this is the union of the graphs. And this shows that solutions are going to be on opposite sides. So if I was to graph both of these inequalities, x is less than or equal to -2. I would need -2 on my number line, a closed circle, and anything less than or equal to it would be anything to the left. And then 1 is my second inequality. It says anything less than or equal to -2 or anything greater than 1. This is -1, 0, 1. Here's 1 here. Anything greater than 1 would be an open circle to the right. This graph looks different than the first one, obviously because the endpoints are different, but also because the answers are going on opposite sides. The first one was between 2 numbers. I could tell from the problem because the problem is a sandwich inequality, which means the variable is inside of 2 numbers, showing that the answers are going to be between 2 numbers. This inequality is this or that, meaning it's either going to be this one or that one. This answer, what numbers are possible solutions of this compound inequality, we could go on forever and ever and ever. Because anything less than -2, less than or equal to, could be -2, -3, -4, -7, we could keep going. Or anything greater than 1 could be like 1.1, 2, 5, 25, anything. We could keep going forever in both directions. So we're going to end today with some examples below. I'll do the first one with you, and then I'm going to have you guys try these on your own. So we are going to be writing inequalities from the graphs. A and B look similar, and C and D look similar. A and B look similar because the answers are between 2 endpoints. When the answers are between 2 endpoints, your inequalities will look something like this. X in the middle, and then you will either have this or this on this side, and then this or this on this side, and then you'll have numbers here and a number here. So it's going to be like a sandwich answer. So you look at the graph, put X in the middle, and then you put the endpoints on both sides. The endpoint for this one is -6, the endpoint for this one is 3. And then you have to figure out what symbols would go there to make sense. And then to figure that out, you look at the circles. Let's start with the 3 first. This graph is showing an open circle at 3, and the solutions are to the left of it. What symbol shows that it's an open circle with solutions to the left of it? Molly?
Less than.
Less than. So this is going to be a less than symbol. This symbol here, if we were just looking at it normally, this is a closed circle. The answers are to the right of it. If I was to just write this graph, closed circle, answers to the right, it would be x is greater than or equal to -6, right? But because the x variable is in the middle, we actually can't use a greater than or equal to symbol because the variable is flipped with the number. the symbol you have to use is less than or equal to. The symbols will always be facing the same direction. So the symbols will always look like that, which is why I said it will either be that, or this, or that. That's because when you have a sandwich answer like this, the inequality is a compound inequality with the word and it's between two numbers. The variable must be in the middle. The one on the right-hand side, x is less than 3, looks normal because the x is what we usually write first. The one that has the number first, -6 is less than or equal to x, looks opposite because we are used to writing the variable first. I'll let you guys try B on your own, but I actually do want to just do C with you, and then you can try D on your own. So C and D look similar because these ones are not between two endpoints. When inequalities are between two endpoints, the answer will look like letter A. When they are going on the outsides of two endpoints, you write both of the inequalities separately. This inequality here would be anything that's less than -5 because it's an open circle at -5 and the answers are to the left. Or you would then write this inequality. This is anything that's greater than or equal to 4. When you have answers going on the outsides, you have to have the word or in the problem. If you have answers between two endpoints, the word and is not actually seen, but the way that you write your answer shows me that it is an and compound inequality. So go ahead and try B and D. I'll give you a couple minutes. Then we will go over them and call it a day. All right, let's go over B and D. So B, I can see the endpoints are -3 and 6. So I know I need and the -3 in this spot. I know I need a 6 over here in this spot. You put the variable in the middle. It doesn't have to be x. It can be any variable, but I'll just use x because that's what we usually use. And then you just have to insert the correct symbols. Usually the one on the right makes more sense because since the answers are to the left of 6, I know it's going to be a less than symbol since it's an open circle. The one on the right sometimes is confusing, but the direction will always go, like it will always open this way to the right. So I know that this is also going to be a less than symbol. And that doesn't mean that the numbers are less than -3 because this says x are greater than -3 because we read it from right to the left when it's like this. So this is going to be -3 is less than or equal to the numbers, which is also less than 6. That would be the answer to letter A. And then letter D, we just solve both of these. Well, we write both of the inequalities separately and join them with the word or. What's the inequality for the one on the left? Less than or equal to is good. Then? Perfect. Or? What's the second one? X is what? Perfect. So this one would be x is less than or equal to -4 or x is greater than or equal to 5. Great job. So tomorrow we'll finish up this section, and then we will start solving them.